Welcome to yet another JetBrains MPS demo screencast. Once again, my name is Markus, and
I'm Vaclav Pech.
Very good. And this time we're going to look at how to extend the base language, i.e. Java, with money, with new literals, new types, new type system rules. We try to focus on different aspects of how languages could be extended in each of our screencasts. We started with a simple statement. We have the decision table for, let's say, fancy notations. And now this time we look at different types, different kinds of new literals. So I guess we should start by demoing how, what you can do once it's finished, as a kind of looking at the result first.
Yeah, I'm sure people love money, so they will appreciate our demo. So first, I'll create a main method, and now we'll do some basic money operations. So let's say we want 10 euro. Notice, all I had to type was, I just typed 10 euro, and it recognized that I want to an instance of the money concept. Now, having that, we might add the money. So we have 10 euro, we might add 20 euro to it. So we might do some math operations with money. We might take 20 euro and, let it come from a method. So whatever, we might get a donation. So now, we get 20 euro coming from a method, maybe loading it from somewhere, whatever.
Yeah, so the regular Java refactoring stuff fits in.
Yeah.
Because this 20 euro thing is simply an expression. It's a money literal, right?
Mm-hmm.
So that should be visible if we kind of look at the concept. If we just mark the 10 euro thing, it should say somewhere in the inspector. Yeah, so that
you can look at a type, which
the type is money, and if you open the inspector, you can see that it is a money literal.
Right.
And money literal is a new concept which extends expression, so it can be used wherever expressions are used.
Wherever expression is expected. So we may well store this in a variable.
Yeah.
Like.
So this also shows that there is a new type, the money type, right? Capital money thing.
Yeah.
So we've had to introduce that as well.
Mm-hmm. Yeah, so we have a money type that represents type. We have a money literal, so we can write, 10 euro, $10.
So where does the euro come from? I mean, if you can, as usual, maybe just control-click on it and see whether there's some magic going on here.
Here we go.
So there is a new top-level concept, the currency definition table, where you can just define a bunch of currencies. And you now could imagine that this could also include, exchange rates, and you could do all kinds of fancy stuff.
Right.
At this point, you just define these things, and from whenever you want to create a money literal, you can refer to any of these currencies.
Mm-hmm. Yeah, so all these currencies are available. You might add them.
So can you add, if you try to add dollars and euros? Is the type
together?
System, is the type system good enough to notice that probably goes wrong?
All right.
Let's just try.
I think at the moment it doesn't.
Yeah, I'm not sure either. So let's just try.
All right. So I'll store this somewhere so we don't have it underlined in red.
Yeah. Right. So the reason why it was red was because it's not a legal statement.
It wasn't complete. Right. Yeah. It was just an expression. Now we need to store it somewhere. Do something with it. Now you ask about 10 euro.
Yeah.
And now we
plus $2. Right. And maybe store it in a variable so it stops complaining.
Right.
Okay, so it does it.
Yeah.
So we didn't add that type checking rule yet. Okay. Maybe you can explore at the end of the screencast how that would be done.
Okay. Yeah. That sounds like a good challenge.
So should we look at the implementation of all of that?
Well, let's have a look. And obviously we start in the structure.
Yeah.
And we should start with...
I guess the currency definition table is the simplest thing
to look at,
right?
Let's start with something simple.
Right.
So this is the place where you can define currencies, right?
Yeah.
Okay. So what do we have? We have...
a collection of currency units.
Yeah, a collection of currency units. And what is currency unit?
That's basically something with a name. So like just the text, the USD is a currency unit with the name USD. Mm-hmm. So that's basically
a base concept with a name. That's basically it.
Yeah.
And you can have a lot of them as part of concurrency definition table.
Yeah.
Currency definition table.
You do too much concurrency stuff.
Yeah, I work on concurrency in parallel. Yeah. No,
Yeah.
so back to currency here. So basically, we use a constant for currencies, and then under that we have a collection of all the units that we allow.
And I mean, the reason why we can add that on the top level here, on directly in our model here, is because the currency definition is marked as can be root, so it can be added at the top level of the model. Okay, so that's simple.
That was easy.
Yeah.
Let's take something more challenging.
Maybe the literal.
Money literal. Here we go.
Right. So that's an expression, so we can use it wherever expressions are expected.
Right.
Makes a lot of sense.
Yeah. And it has an integer constant for amount, and it references a currency unit.
Right. So it points to one of these currency units we have defined in this currency table.
Right. So and it takes currencies from there.
Yes.
Right?
How does it find them? I mean, how does it know where to look for those currency units? We had to define, usually we had to define a scope that says how do you find the potential targets for that guy, for that reference. We didn't do that because the default scoping is that it just looks globally in the model. So that would have to be made a little bit more clever in a real system.
So you can have more of these
several tables, and you can maybe define in a Java class which of these currency definition tables is relevant for this class. You can do all kinds of things. Now, just all currency units that are defined anywhere in the same model are just visible. It's like default simple stuff.
Okay.
Good. Okay. So I guess, that's the money literal.
And this is how it looks like in the editor.
Yeah.
Here's the syntax. We see amount, and then we see the currency.
The name
which
of the currency.
Which is name of the currency.
Yes. So if we go back to the sample code, we can take one of these currency literals, we can mark it, and we can ask it for its type with Control-Shift-T, and it says the type of one of these guys is money. So there must be a type system rule somewhere. So we can go back to our money literal here and look at its type system rule, and we just say that the type of a money literal is just the money type, money, which to make it fit with the type system framework, we can go to that guy, extends the type. Type.
So it has to be a type.
Yes.
And by extending type, you make it a type.
Actually, from MPS's perspective, it doesn't have to do that. Any node can be a type of another node, but base language expects types to inherit from the base language concept, capital T type. Right, it's good practice.
Okay, yeah.
So the reason why initially when we tried to add euros and dollars, that wasn't the problem, was that the money type doesn't know about the currency.
Right.
So that would be the place where we took in. Okay. So I guess one of the coolest features is the editor support, right? If you just if you remove that guy for the time being and you put the check keyword again, +2, then of course there's an error because adding euros and 2 is not valid. There is no type calculation rule that knows how to deal with euros and just numbers. Now, to make that 2 into a currency literal, you can just type the currency. How does that work? Because that is editor magic, right? Normally you would have to say, let's do it the
complex way.
Right. You would select a money literal. It doesn't even show up because we probably gave it some kind of alias. Money literal. It's money. Okay, right. Should have known that. So we can just type money, and then we can enter the amount and
currency.
Control space, the unit. And that's of course a really bad editor experience.
But that's the default, right? That's if you don't do anything extra,
right,
beyond defining the editor.
Yes.
So this is what you get.
Right.
If you want to be, if you want to have more smoother experience with the editor, you have to define define actions.
Right.
Here we go.
So actions are basically customized editor behavior. Right. And this is a so-called site transform action, which basically let me say it in plain English and point to the places, right? So there is a site transform action that if on the right side of an integer literal you type text that fits that condition, we'll talk about that in a second, then create an instance of money literal using this procedure to actually create it. Right? That's the story behind one of these guys. So when we try to see whether the text somebody types on the right side of a money literal is something that is kind of triggering making it, on the right side of an integer literal, whether that text should trigger a transformation to a money literal, the way we do it is we just grab all the currency definitions. You know, we go to the model, we grab the currency definition table and grab all the units, and we check whether one of them starts with the text we're typing. Pattern is the text we're typing. So if it starts with one, we just return that guy, otherwise we return null. If we return something, that means it's matched, it's valid, it's something that this action should address.
Yeah, so it triggers the action.
Right. So once we trigger the action, we do another check where we make sure that it's not just starting with the pattern we've typed in, but actually equals. We have to finish typing euro, and then here is the transformation that's going on. Well, we create a new money literal, set the unit to the one we've identified based on the stuff we typed. We set the amount to the value of the integer constant, which we are replacing because we are on the right side of it. And then we replace the source node, the integer constant, with the money literal we've just created.
Yeah. Okay. Well, that's pretty clear and clever. You know, it makes experience in the editor very, very smooth.
Yeah, and actually that's something people have to do to make, as you say, to make editing experience not just smooth, but I would even say acceptable. Because nobody wants to use control space to create these objects all the time.
Yeah.
Right. So that's the interesting thing. Now, why can we add money literals, and why does it complain if we add 10 euros plus 5? Not euros, but just 5. So how do we override the plus operator so that it can do these additional calculations? And the way this is done is obviously done in the type system. And here's a new concept we haven't discussed yet, and that's the overloaded operations container. And the trick here is that usually the type system rules are, as we've seen in previous screencasts, are defined as these inference rules. So we establish equations and the solver, the unification engine, tries to solve them. Now for binary operators, this is a bit tedious. So there is a special support for left-right kind of argument thingies, the binary operators. And that is based on these overloaded operations guys.
Right, so this is the place where we say what should be the resulting type of when you have two money literals and you combine them.
Yeah, if you have a plus expression with the money on the left and the money on the right, then return another money.
Yeah.
And so the way this is done is that in base language there are already a number of those guys for the int string whatever Java has. And if you want to overload an operator with your own typing rules for your own new kinds of things, then you just provide additional,
additional
rules
rule.
like this.
Yeah.
And so that's what we did here. We provided for plus and minus, as an example, a rule for the case where left and right is money, and it becomes money. Now, if we have on the left money and on the right integer, there is no rule.
Yeah, so that's why it
fails.
complains.
Yes.
But we could easily do it here. Like, for example, I could imagine a rule that would say if we have money on the left-hand side and integer on the right-hand side and the operator is multiplication, then you might want to multiply the amount of the money.
So that would be fine, right? So let's try, right? So let's just go here. Let's duplicate that guy. Let's make that the I guess it's this one, mul expression. We remove the minus, right? We make the money on the left and an integer. I should actually use the quotation I'm looking for. So, and an integer on the right. Then the result is money, because if you multiply money by 2, then that's still money.
Right.
Let's see if this works. This is, by the way, this is unrehearsed. So
yeah. So let's see.
Google, rebuild, please. Hello. Now we have to say something while the progress bar is.
Well, already started getting some some errors down.
Yeah,
there.
I know. I think the reason is we've changed a couple of things. Actually, this should go away now. So the thing is, you will get this maybe sometimes when you work on your own projects, and what it says is that there is an editor declaration which references a concept it can't find. And what we did actually when we prepared this screencast was we've deleted a concept, and unfortunately the editor
wasn't deleted, right?
Yeah, it remains here as a null editor. That could be argued as a bug in MPS. I'm not, people disagree.
Opinions vary.
So we just delete the unnecessary editor, and then things are fine.
So now we'll be able to multiply money.
Hopefully. That's actually a good idea.
Yeah, exactly.
People have always generated when I told them that code generation is good for business, right? They said, why do all the interaction? You should have a revenue generator, not a code generator.
We are very close to that at the moment.
Okay, so if we go here, actually, why don't you type? You're used to the keyboard layout. So, €10.
So on left-hand side we have money, and now we do multiplication, right?
With 3, maybe.
Nah, come on.
And assign it to something so it shuts up.
And we store it in...
Cool, that works.
My money. Oh, my money. Yeah, so now multiplication works, but only if money is on the left-hand side.
Yes.
Right? So for the opposite direction, we would have to create another rule.
Which is a little bit annoying, I think, but that's how it is, yes. Okay, so maybe one thing that's still missing is looking at the generator.
Yeah.
I don't think we should elaborate that too much, because what we're doing is basically mapping that to a runtime library. So maybe we should give a very brief overview and then keep it at that.
Okay, yeah, let's stay brief, since this is really nothing much than just translating this code into the runtime library. So now let me find my way around. So we are money literal. Here we go. And here is the generator. So when the generator discovers money literal, it will fire this rule, and this rule will transform the money literal into into creating a new instance of class money, but this time it's the runtime class money.
Yeah. So can you just
show
that?
The library?
I mean, just right. So
can we jump to there directly?
Sure.
Here we go.
Right.
So this is a class. At the moment, this is written in MPS. You could have it written in Java if you want it. You
mean outside in any other IDE and just use the jar file?
Exactly. So from any jar file, you have a Java class in there, so you can instantiate it here. Right. And we give it the constructor. We give it 2 arguments. Well, if we check again the constructor takes 2 arguments, integer and string. So that's what we give it.
Yeah. So in some sense, the what we've done here is we've provided a custom syntax around a possibly existing framework.
Exactly.
So the program expressed with the DSL populates data structures provided by the framework. This is one of the ways Martin Fowler, for example, advocates building DSLs. So you first build a framework that does the semantics, and then you build a language around it. For syntax and type checks and other stuff like that.
And that's exactly what we're doing here.
Okay.
I think, that explains the generator too.
Yeah. And people can always get at the code at GitHub.
Yeah, as usual.
And
at GitHub, so get it, play with it.
Yeah, there should be a link somewhere around this video once you see it.
Preferably on the same page.
Okay, that's it, I guess. Thanks for watching.
Good. Thank you. Goodbye.
Bye.